This video is over lesson 96, graphing quadratic functions. And so for this lesson, we're going to be using the handout graphing quadratic functions. And so if we take a look at that first here, you'll see that I have this set up for two different forms. I have it set up for the standard form of quadratic function, and I also have it set up for what's called the vertex form. So this lesson is going to focus on the standard form, so we don't need to worry about that. Just focus on the standard form for right now. So first of all, as we've learned in a previous lesson, that the axis of symmetry can be found by using x equals negative b over 2a. So b being the linear coefficient and a being the leading coefficient or the quadratic coefficient. So we calculate that axis of symmetry. Then we find the vertex and graph it. So the vertex, this is your x value. So whatever this comes out to be, that's going to be your x value. But then if we take this x value and plug it into the function we started with, then we'll find a y value that goes with that x value. Next up, we find another point. So just find some other point and graph it and its reflection. So the y-intercept is often an easy one to find if it's in standard form, because remember that whatever c is, that is the y value of your y-intercept. So that can be a nice one to go with. You don't have to go with that, but it, like I said, can be a nice one to go with. And then 4, we find a second other point. So some other point other than the ones you've already found. And then we graph it and its reflection. So at this point, we have a total of 5 points. So as you can see here, so we've got the vertex, and then you find a point and its reflection. And you find another point and its reflection. And then finally, number 5, we draw the parabola through the 5 points. You could go with more points than 5, but I would say 5 is a minimum. If you really want to get the shape of the parabola, 5 is really a minimum. So with that being said, let's go ahead and try this out. So our first example, as we can see here, is going to be y equals x squared plus 4x plus 5. So one of the things that I want to point out to you is that f of x basically works as our y value. So when you see those are somewhat interchangeable. So the first thing I'm going to find is, what is my axis of symmetry? Now, in the end, I'm going to need a bunch of points. So what's going to help me out here is if I make a table of values. So I'm going to make a table of values there. And what I'm going to do here, I'm going to make my numbers about double space big just so they're really nice and obvious. So there's going to be my first number, my second number. Here's going to be my third number right there. And so in the middle here, the vertex is going to be on the axis of symmetry. So I'm going to put my negative b over 2a right here in the middle. So b is 4, a is 1. So 4 over 2 times 1. So 2 times 1 will be 2. 4 over 2 is 2. But then we got to make it negative. So my axis of symmetry is x equals negative 2. So to find the vertex, I'm now going to take this and plug it into my equation. So a negative 2 squared would be a positive 4. 4 times a negative 2 would be a negative 8. So I'd have 4 plus negative 8. That gives me a negative 4. And then negative 4 plus 5 is a positive 1. So my vertex here is negative 2, comma 1. That's my vertex. Now we just go symmetrically. So considering a negative 2, again, the y-intercept is nice. So if I go negative 1 and 0, that would give me 2 more points, and then I can find their reflections to finish it off. So 0 is easy because remember 0, this is going to disappear, that's going to disappear. So my y-intercept is 0, 5. And that means that since this is 2 to the right, if you think about your number line, going from negative 2 to 0 is going 2 to the right. So if I go 2 to the left, this should have the same y value. Okay. So if I find negative 1 now, negative 1 squared is just 1, positive 1. 4 times negative 1 would be a negative 4. So 1 plus negative 4 would be a negative 3. And then plus 5, negative 3 plus 5 would be 2. So that means since this is 1 to the right on the number line, 1 to the left would also have the y value of 2. So you can see how the y values are symmetric there. Now considering this, our vertex is at negative 2, 1. So that's a little off to the left from the origin and a little bit up. And then since my leading coefficient is positive, and we can see these values also, they're going up, this is going to open upwards, which means I really don't need a lot of space in my graph going down, but I need a little bit of space going up and a little space going left and right. So I'm going to go ahead and graph this. I'm going to make 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then I'm just going to go 1 down here, and I'm going to go up 1, 2, 3, 4, 5, 6. So once you have your points, you can kind of decide on what space you need in your coordinate plane. So this will work for me. So the vertex, I'm going to start with the vertex negative 2, 1. And that's my axis of symmetry, remember. So we don't have to write this in. I'm going to do it in red pen as a dashed line. That's my axis of symmetry. So my next point that I found was the origin, or excuse me, not the origin, the y-intercept, excuse me. So 0, 2, 4, 5. So if I go symmetrically on the other side, there's my negative 4, 5. My negative 1, 2, so negative 1, 2 is right there. So symmetrically, on the other side, it would be right there. And then we draw the graph. So this should be a nice curved bottom to this. A parabola does not have a sharp corner to it. It's a curve all the way through. So no sharp corners on a parabola. And there it is. That's our first example. For our next example, we're going to take a look at the equation y equals 3x squared plus 18x plus 13. So likewise, I'm going to make a table of values. And so in the middle, once again, I'm going to put my axis of symmetry. So in this case, B is 18 and A is 3. So 18 over 2 times 3, 2 times 3 is 6, 18 over 6 is 3, and we're going to make it negative. So negative 3, x equals negative 3 is my axis of symmetry. Now we're going to go ahead and find our vertex. So a negative 3 squared would be 9 times 3 is 27. 18 times a negative 3 is a negative 54. So a 27 plus a negative 54 would give me a negative 27. And then to finish it off, negative 27 plus 13 would be a negative 14. So 3, negative 14 is my vertex there. All right, and then we just need to go a little bit on each side. So I'm going to go over to, let's go over to negative 1, just because negative 1 sounds easy to plug in, and then 0. And that'll give me my y-intercept. So the y-intercept is easy, it's just going to be 13. And then negative 1, you could have chosen negative 2 there instead. It really doesn't matter, it's up to you. For that matter, I could have chosen negative 2 and negative 1. It's totally up to you what you choose there. but we just need to choose two different things. So I chose those just because I thought they'd be easy to plug in. 0 was easy to plug in because I know then it's just going to be C, so 13. And then I figured a -1 was easier to plug in than a -2. So smaller numbers usually are easier to calculate. So on the other side, going from a -3 to a -1, that's a distance of 2 away. So if I go 2 on the other side, that'd be a -5. And then if I'm at a -3 on a number line and I go to 0, well, that's moving 3 units to the right. So if I move 3 units to the left, that'd be a -6. Okay, so now let's find our values. So if 0 is 13, then symmetrically, -6 will also produce 13. Now let's go ahead and figure out what happens when I plug in -1. So a -1 squared is just 1 times 3 is 3. 18 times -1 would be a -18. And so I might actually just take my 3 plus my 13 as a positive 16, and then plus the -18 is a -2. So from there, if that's a -2, then symmetrically, that's a -2 as well. So now I'm looking at these numbers and I got to kind of plan how big do I want to make all of this. So first of all, I see I've got a lot going here on the left, so I don't need as much to the right. I do drop down all the way to -14, and I go all the way up to positive 13. So when I'm looking at that, I'm thinking, I might want to go with a scale of at least 2 here. And so if I do that, I want to move to the left. I need at least to go to -6, so I'm going to go a little beyond that. I'm going to go at least to -8 or -10. So I got positive 2, -2, -4, -6, -8. And so going down, I've got to go to -2, 4, 6, 8, 10, 12, 13. I've got to go at least that far down. So again, -2, -4, -6. Don't need to label all of them, really just need to get the gist of it. So going up, I've got 2, 4, 6, 8, 10, 12, 14, 16. So likewise, 2, 4, 6, just enough to get the gist of what's going on here. And now we plot our points. So a -3 would be about halfway there, and then a -13, so that was -6, 8, 10, 12, 13 would be right there. So that's my -3 comma -13. Oh, I'm sorry, -14. It's supposed to be -14, isn't it? So that's actually going to go all the way down here. And then I have, that will be my axis of symmetry then right there. So my axis of symmetry is going through right here. So now at -1, so that's right there, I'd go down to -2. And so you can see symmetrically that's going to put our other point right there. And then finally, my y-intercept 0, 13, so 0, that's 6, so 8, 10, 12, 13. Zero comma 13, 8, 10, 12, 13. So going symmetrically on the other side would put us right there. So you can see here this one produces a much more narrow parabola. So it's still a curve though. At the bottom it'll curve, comes up. If you end up having to erase this once or twice to actually hit those points and have a nice curve, I understand. I've had a lot of practice doing this over the years, and even sometimes I hit a point where I need to go back and erase a little bit myself. So, but there it is. And we're going to go to the back now, and we're going to take a look at another example. So for this one, I would like to take a look. Oops, I got 2 sheets of paper there. I would like to take a look at the equation y equals 5x squared plus 4. So just like the others, we're going to start with our table of values. 1, 2, 3, 4, 5 points we need at least. And in the middle here, so there's my first, second, there's my third, we're going to put our axis of symmetry. So B is the coefficient of your x. It's the linear coefficient, but you'll notice we don't see x here, which means that B is actually 0. That's what would cause that to disappear. A is 5, so this is really 0 over 2 times 5. Well, of course, if it's 0 on top, that means the fraction is 0, and a negative 0 is really just 0. And then if I plug 0 in, that'll disappear and leave just a 4 behind. So it turns out this time we cannot use the y-intercept as one of our other points because the vertex is the y-intercept. So let's just choose some other points that would be nice and simple. I think the simplest that we can get is just going to 1 and 2, which means on the other side, I'll have -1 and -2. So if I put a 1 in here, 5 times 1 squared is 1 times 5 is 5, plus 4 is 9. So that means if I plug in -1, I'll also get 9. If I plug in 2, 2 squared is 4, times 5 is 20, plus 4 is 24. And so for this one, we may have to use different scales for our x and our y. My x values are moving very slowly, just -1, -2, -1, 0, 1, 2. So there's not much movement there, but this is going from 4 all the way up to 24. So it may actually make more sense on this one if I make my coordinate plane and I'm just going to go ahead and use a normal scale for my x-axis, but I have to label it because for my y-axis I'm going to be using a different scale. So here I'm going to jump by 4s. 4, 8, 12, 16, 20, 24. So since we have a different scale on each of these, we do need to label that. Now it's just a matter of graphing your points. So 0, 4, that's right there. So the y-axis is my axis of symmetry this time. So 1 unit to the right takes me to 9. That means 1 unit to the left also takes me to 9. 2 units to the right takes me all the way up to 24. So 2 units to the left also takes me up to 24. And just as we've done before, draw in your parabola. Make sure that's not a sharp point down there. And we've graphed it. So ladies and gentlemen, we're going to throw back now to one of the labs that you did recently, where in the course of the lab you ended up talking about the zeros of a function. So to define that here in our notes, 0 of a function. So a 0 of a function is any x value such that when we use that value in the function equals 0. So basically it's any x value that produces a result of 0. Hence its name is a 0 of the function. It makes it 0. And we find these sometimes by graphing. So if I go back to my first example, you'll see there's nowhere where the y value is 0. So this function actually has no zeros. This function down here has 2, and I'm not quite sure where they are. I know this one over here is somewhere between 0 and -1, but I don't know its exact value. And in our last example, likewise, you can tell that there are no zeros. We could always have 1 0 as well, but that's only when the vertex hits the x-axis. So remember that we can have 2 zeros, 1 zero, or no zeros. So the zero of a function is where the function is 0. So we're going to talk about real quick here finding zeros. One way to find zeros is to graph. Now that's not always going to work out nicely. For example, our second example that we did today, we can tell there are 2 zeros, but it's a little trickier to find out what their actual values are. So graphing isn't always the best option, but it is an option. 2, as you did in the lab, use a graphing calculator. Forgot the C there. Calculator, there we go. So your calculators actually have an option where you can find the zeros on the graph. You can find those values. And then 3, you can solve the quadratic equation. And so remember that a quadratic function is of this form. Of a standard form of a quadratic equation. The standard form of a quadratic equation takes from the quadratic function. So if the quadratic function is ax squared plus bx plus c, then this is ax squared plus bx plus c. But the big difference here is the quadratic equation, instead of having 2 variables, because remember this is basically our y, actually only has 1 variable. It only has x, because it is always equal to 0 in its standard form. So what we do in order to get an equation into a quadratic equation into its standard form is we actually solve for 0. We want all of our terms together on one side of the equation. So if we solve that and find out whatever x values make that true, we find the zeros of the function. So, ladies and gentlemen, sometimes though that can be a little difficult with the skills that you have. There is a skill coming up later on that I'm going to introduce you to right now that is going to help us find the zeros of a function, of a quadratic function. So for this though, we're going to leave our graph paper behind. And I'm going to ask you to grab a sheet of lined paper. We're going to switch over to lined paper. And we're going to title this Supplemental to Lesson 96, Quadratic Formula. And I'm going to give you a heads up right now that this is not in the book's lesson. However, I do want you to have it. I want you to introduce you to it now, so that way when it comes up in a later lesson, you are all set and you're familiar with it. So the quadratic formula. So we got a lot of quadratic stuff going on. We got quadratic functions. That's what we were graphing. We've got the quadratic equation. That's the one where you've got all the stuff equal to 0. And then finally, we've got this third thing, the quadratic formula. And so the quadratic formula says if ax squared plus bx plus c equals 0. So essentially it says if you have a quadratic equation in standard form. That's what that's starting with. So if that, then, and I want you to make this double big so it's nice and readable here, then x equals. So this is going to tell you how to find those x values that make that equation true. And it actually starts with our axis of symmetry. And so it actually starts with a negative b Well, then we're going to get that negative up there with the b, and then it's going to be over 2a. Now you'll notice I left some extra space here because there's more to it. You may or may not have noticed that throughout your homework you've been given this radical expression that you've been asked to plug values into to solve. Even if you haven't noticed it, maybe you'll go back to some lessons and notice it. But the next part of this is actually a plus minus. The plus minus because it's a radical. Remember that when we solve things with an x squared, we have to take a true square root, which results in a plus minus. So we got a plus minus here, and then inside the radical we have b squared minus 4ac. This is a formula that you are going to want to memorize. You need to memorize this. It's going to be useful a lot in the future. So x equals a negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And again, it all starts off with that axis of symmetry, but then we add or subtract, and we add or subtract, remember, because this is symmetric. So if you add this value, you go to the right a little bit. If you subtract this value, go to the left the same amount. So ladies and gentlemen, we're going to take a look at a few examples of this. So let's start off with y equals x squared minus 6x plus 9 as our equation. So if that's my equation, then to find the zeros, we're going to solve x squared minus 6x plus 9 equals 0. So this means that my a is 1. So a is 1. This means that b is a negative 6. It means that c is 9. So therefore, my zeros are going to be at x equals a negative b. So a negative negative 6 would just be a positive 6, plus or minus radical b squared. So that'll be my negative 6 squared. Don't forget the parentheses since it's negative. Minus 4, a is 1, c is 9. And all of that is over 2 times a, 2 times 1. And so we simplify it. So if I simplify this, then I'm going to have a 6 plus or minus the square root. Now negative 6 squared is 36, minus 4 times 1 times 9 is 36, all over 2 times 1 is 2. Well then, of course, 36 minus 36 is 0, and the square root of 0 is, well, 0. So if you take 6 plus 0 and 6 minus 0, that's really the same thing. So it turns out this one actually just has a single answer of 3. So we only have one 0, and that 0 is at 3. Let's take a look at another example. This time, let's say you were given the equation y equals x squared minus 3x minus 10. So then to find the zeros, we're going to solve the equation x squared minus 3x minus 10 equals 0. Thinking this through real quick. So a is 1 here, b is a negative 3, and c is a negative 10. So using the quadratic formula, x equals a negative b, so again a negative negative 3 would be a positive 3, plus or minus the square root of b squared, So that'd be negative 3 squared minus 4, a is 1, c is negative 10, all over 2a, 2 times 1. So real quick here, I'm going to notice here I got 4 times 1 times a negative 10. Well, that negative and that minus really can cancel each other out. That's going to make things a little easier. So then this is going to give me 3 plus or minus the square root of 3 squared, negative 3 squared, which is 9. And 4 times 1 times 10 is 40, all over 2. Well, we can tell here 9 plus 40 is 49. And the square root of that is, of course, 7. So this is 3 plus or minus 7 all over 2. So therefore, the zeros are at, well, 3 plus 7 is 10. Divided by 2 would be 5. Or, since it's x equals, so x equals 5. Or x equals, well, 3 minus 7 would be a negative 4. Divided by 2 would be a negative 2. So my zeros are at 5 or negative 2. So we've got 2 zeros that time. And then one last example here. One last example. We're going to take a look at the equation y equals a negative 2x squared minus 3. And so for this one, the zeros are going to be wherever negative 2x squared minus 3 equals 0. So here, my a equals a negative 2. This is my constant, so that's a negative 3. So there is no b here, which means that b is 0. So I'm ready to plug things in then. So x will equal a negative b, so negative 0 is really not going to be anything. That's going to disappear. So this is really just going to be plus or minus the square root of b squared, well, that's 0 squared. Then it'll be minus 4 times a, which is negative 2, times c, which is a negative 3, all over 2a, so 2 times negative 2. So if we simplify that, I've got a plus or minus, and then that will cancel with that. So 4 times 2 is 8, times 3 is 24, but it'll be a negative 24, all over negative 4. And this is where we have a full stop. We cannot take the square root of a negative 24. So this is where we would say no real solution. However, since what I'm looking for is zeros, if there is no real solution, what does that mean about my zeros? Well, there are no real numbers that produce a 0. So the answer actually to the question here, where are my zeros, would be no zeros. If there's no real solution to your quadratic formula, there are no zeros. And that, ladies and gentlemen, is the end of our lesson.